Hello students. Hello and welcome to this video. In this video, we will go through question number 61 to 70 of binomial theorems. The link to download the PDF will be in description, as well as at the end, I will show you my question and answer website, which I have developed for you. Where you can come and ask questions related to mathematics, because YouTube is not really suitable for discussing mathematics in comment box. So we start from question 61. If A, B, C, B3, B the 3, these are in mixture, consecutive terms in the expansion of the powers of 1 plus x, prove that the exponent is 2ac plus ab plus bc upon b square minus ac. So we let the index of the power be n and let abc be the rth, r plus 1th, r plus 2th constant respectively in the expansion of 1 plus x to the power n. So A is equal to NCR minus 1, B is equal to NCR, C is equal to NCR plus 1. Now A upon D is equal to R upon N minus R plus 1, that is N plus A is equal to R A plus B. B upon C is equal to R plus 1 upon N minus R, that is Bn minus Br is equal to Cr plus C. Okay, that implies that Bn minus C is equal to R into B plus C. So from these two equations, we find N as 2ac plus ab plus bc upon b square minus ac. Question 62 says that if the 14th, 15th, and 16th term in the expansion of 1 plus x to the power n are in AP, find n. The quotient of 14th, 15th, and 16th terms would be NC13, NC14, and NC15 respectively. Since these are in AP, 2NC14 is equal to NC13 plus NC15. We compute the value, we substitute the formula, and we find n is equal to 23 or 34. Question 63 says that if three consecutive terms in the expansion of 1 plus x to the power n be 56, 70, and 56, find n and the position of quotients. So let the three consecutive terms be rth, r plus 1th, and r plus 2th. Then NCR minus 1 is equal to 56, NCR is equal to 70, and NCR plus 1 is equal to 56. N is missing here. So from the first two we divide, we get r upon n minus r plus 1 is equal to 4 upon 5. And from the last two we have upon division n plus 1 upon r, n minus r is equal to 5 upon 4. We solve these two equations, we get n is equal to 8, r is equal to 4. Question 64 says that if three successive quotients in the expansion of 1 plus x to the power n be 220, 495, and 792, find n. So we let the consecutive terms be rth, r plus 1th, and r plus 2th. Then NCR minus 1 is equal to 220, NCR is equal to 495. Again, n is missing here, NCR plus 1 is equal to 792. So from the first two, we have r upon n minus r plus 1 is equal to 4 upon 9. And from the last two, we have r plus 1 upon n minus r is equal to 5 upon 8. So we solve these two, we get n is equal to 12. Question 65 says that if third, fourth, and fifth terms in the expansion of a plus x to the power n be 84, 280, and 560, find a, x, and n. So third term would be NC2 a to the power n minus 2x square is equal to 84. T4 is equal to NC3 a to the power n minus 3x cube is equal to 280. And T5 would be NC4 a to the power n minus 4 x to the power 4 is equal to 560. So we divide first two, we get 3 upon n minus 2 times a upon x is equal to 3 upon 10. And from the last two, we have 4 upon n minus 3 times a upon x is equal to 1 upon 2. We further divide these two, we get 3 times n minus 3 upon 4 times n minus 2 is equal to 3 upon 5. So from this, we get n is equal to 7, which gives us x is equal to 2 and a is equal to 1. Question 66 says that if 6, 7, and 8 terms in the expansion of x plus y to the power n be 112, comma 7 and 1 upon 4, find x, y, and m. So we proceed like previous problem. T6 is NC5 x to the power n minus 5 times y to the power 5 is equal to 112. T6, T7, this should be T7. NC6 x to the power n minus 6 y to the power 6 is equal to 7, and T8 is equal to NC7 x to the power n minus 7 y to the power 7 is equal to 1 upon 4. So from the first two, we have 6 upon n minus 5 into x upon y is equal to 16. And from the last two, we have 7 upon n minus 6 times x upon y is equal to 28. We divide these two, we get an equation in n, and upon solving, you get n is equal to 7, and thus x is equal to 4, y is equal to 1 upon 2. Question 67 says that if A, B, C, and D be the 6th, 7th, 8th, and 9th term respectively in any binomial expansion, prove that B square minus AC upon C square minus BD is equal to 4A upon 3C. So let the binomial expansion be x plus y to the power n. Then A becomes NC5 x to the power n minus 5 y to the power 5. And similarly, B is the 7th term, C is the 8th term, and D is the 9th term. So we divide the two consecutive values or terms pairwise. To get, we have this b upon a is equal to n minus 5 upon 6 into y upon x, and so on. So from first two, that is these two, we have b square upon ac is equal to 7 times n minus 5 by 6 times n minus 6. And from these two, we have c square upon bd is equal to 8 times n minus 6 upon 7 times n minus 7. So we subtract 1 from both. Okay? We get v square minus ac upon ac is equal to 7 times n minus 5 times minus 6 times n minus 6 upon 6 times n minus 6. Now c square minus bd upon bd is equal to 8 times n minus 6 minus 7 times n minus 7 upon 7 times n minus 7. And we divide these two, we get b square minus ac upon c square minus bd is equal to 4a upon 3c. Question 68 says that if the four consecutive coefficients in any binomial expansion be a, b, c, and d, then prove that a plus b upon a, comma b plus c upon b, comma c plus d upon c are in HT, and bc plus ad into b minus c is equal to 2 times ac square minus b square d. So we left a, b, c, d, 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 r plus 1h, r plus 2h, and r plus 3h term of a binomial expansion x plus y to the power n. So a is equal to NCR minus 1, b is equal to NCR, c is equal to NCR plus 1, and d is equal to NCR plus 2. So b upon a is n minus r plus 1 upon r. That is a plus b upon a is equal to n plus 1 upon r. C upon b is equal to n minus r upon r plus 1. That is c plus b upon b is equal to n plus r 1 divided by r minus 1. And similarly, c plus d by c is equal to n plus 1 by r plus 2. So clearly, a plus b upon a, comma b plus c upon b, comma c plus d upon c are in H2. Now, bc plus ad times b minus d, we substitute the formula and evaluate, and then you can prove that bc plus ad times b minus c is equal to ac square minus b square d. The calculation is left up to you. Question 69 says that the coefficient of the 5th, 6th, and 7th terms of the expansion 1 plus x to the power n are in AT. Find the value of n. So 5th, 6th, and 7th terms coefficients are NC4, NC5, and NC6. Given that these are in AP, 2 times NC5 will be equal to NC4 plus NC6. We substitute the formula values from the formula, we get n is equal to 7 or 14. Question 70 says that if the coefficient of the second, third, and fourth terms in the expansion of 1 plus x to the power 2n are in AP, so that 2n square minus 9n plus 7 is equal to 0. So proceeding like previous problem, 2 times 2nc2 will be equal to 2nc1 plus 2nc3. We substitute values from formula and simplify to get 2n square minus 9n plus 7 is equal to 0. And with this, we come to the end of 70 problems in binomial theorem. Now I'll show you my website where you can download the books from. So you can come to my website astrovaku.org. I don't know why it is so slow. It is looking up. Okay. So second, third, and fourth links are of algebra, trigonometry, and combinatorial. You can download the PDF. The PDF will not have the date. So you can take this date and add it to the PDF so that after 15 or 30 days, when you come back next, if the date has changed, you can download again and update the date. I cannot put the date in the PDF itself because that will make the existing link invalid. Also, if you want to ask questions to me, you can come to my website, pundika.astrowork.org, and make a login here and you can ask questions. You have tags here for you: algebra, calculus, geometry, coordinate mathematics, and trigonometry. Probability is also there. So you can come and ask questions related to these subjects, and I'll be most happy to answer your questions. So with this, I will end this video. I hope that you are enjoying this playlist and finding it useful. So we'll meet again tomorrow with 10 more problems on binomial expansion. Thanks a lot for watching the video, and stay curious, keep learning, and most importantly, enjoy.